So hi, this is the continuation of our theory of errors introduction, which is we're going to discuss the difference between your precision and accuracy, including the probability of statistics that we are going to employ in this subject. So we are going to start with the precision and accuracy. So we have here the term discrepancy. This is the difference between the two observed values of the same quantity. So kung nag-measure ka 2 times, so the difference of those observations, that is called the discrepancy. So when we say precision, as we all know, this is the degree of refinement or consistency ng individual measurement mo of a group of observation and is evaluated on the basis of this discrepancy size. When we say naman accuracy is an absolute nearness of the observed quantities to the true value. So, how near are you from the estimated true value or gano'n ka kalapit sa nagiging target natin na value or yung ating MPV. So I have here illustration if we are going to differentiate the precision and accuracy using the target. And as you can see this illustration, the individual data, which is the blue one. So medyo closer to each other yung kanyang value, which means precise yung kanyang measurement. However, they are very far from the target. So in this presentation or this illustration, this type of measurement are precise. However, this is not accurate. So this illustration naman, the individual measurement are not close to each other. However, they are very near. Individual observation are very near to the target. So this is not precise, but it is accurate. For illustration number 3, kung makikita natin, very disintegrated yung value ng every measurement. Not very close ng every individual measurement. And also, they do not meet at the target. Sobrang layo nila sa target. So this, in this illustration, then the measurement are made not precise and not accurate. So unlike this one, so very close in every observation and they meet at the target. So this is precise and accurate measurement. So this is an actual field scenario in which to observation of the distance AB with the unknown length, gumagamit siya ng tape which measures 100 feet long, which is actually, meron siyang error which is too long of 0.050. So, in actual, yung length pala ng tape is 100.050. So, may error na yung tape na ginagamit. So, at first measurement, 453.27 yung kanyang nakuhang length ni AB. For the second measurement, we have 453.272 feet yung nakuha niyang measurement. So, as you can see in the value, first and the second observation, medyo closer naman yung value. So, this is precise, but we cannot say that it's accurate since we don't have the value of the most probable value or the true value. So, if we divide the first observation with the second observation, so we can get a most probable value of, I guess, 453.271. So, hindi nila na-meet yung target na, or estimated true value na 453.272. So, how can we say that, how can we prove that our measurement is made precise? So, you have here the formula in computing the precision of our survey. Okay? So, to determine the precision, so this is just the difference between the observed value, kung dalawang observation, over, or it should be divided by the most probable value. So, yung ating most probable value, this is just the average between the observation, and you take it the sum of the answer would be 1 is to 220,000. So, that is very large na. So, we can see that this observation is very precise. So, how can we say that the measurement made is accurate? So, when we say accurate, very, yung distance niya from the target, o yung ating true value is very near. So, to determine the accuracy of the measurement, pwede natin, so, this formula, so, 0.453, yung ating value na measured, times 0.50, that is the error we commit yung ating systematic error ng tape over yung ating MPV. So, if we take the ratio, numerator 1 divided by 453.71, so this will become 1 is to 2,000. So, compare sa precision with 200,000, so, hindi siya gaano ka-accurate yung ating value. So, if we compare to accuracy of 1 is to 10,000, if the standard accuracy na pwedeng ma-meet is 1 is to 10,000, then, therefore, this 1 is to 2,000 do not, hindi siya nakaabot sa 1 is to 10,000 na accurate na value. So, this measurement is not accurate if the standard is 1 is to 10,000. However, if the standard is mga 1 is to 1,000 lang, accepted na, then this measurement is accurate. So, we can say that this is accepted. So, how can we eliminate our mistakes and systematic error? Paano natin ma-eliminate? Very common, number 1 is we're going to perform the observation using the standardized repetitive procedure. So, kailangan natin paulit-ulitin pag-determine yung data. Comparing several observation of the same quantity. So, if we're going to compare yung ating mga results, and we can determine kung medyo itong data na to medyo malayo yung malayo sa hindi sa precise compare sa other measurements. So, pwedeng baka magiging cost lang ng malaking mistake. So, pwedeng mong tanggalin. Making a common sense estimate and analysis. Kailangan on the field pa lang i-analyze mo na yung data mo. Dapat alam mo na kung ano yung magiging figure out, yung magiging result ng survey mo. Casting out the doubtful value, kung alam mo yung this distance is parang doubtful ka sa magiging result, and you are doubtful for this measurement. For example, 100 first measurement mo ng a distance, 100, 199, 100, and the next measurement is 80. So, medyo doubtful ka na sa 80 because some of the measurements are very close to each other. So, you can cast out. So, tanggalin mo na yung nagkakos ng mistake. We have here, systematic errors can be calculated and proper corrections applied to the observation. Yes, for example, yung gumagamit tayo ng mga tape, which is nagka-cause siya ng error through the temperature, yung mga sag correction natin, pwede natin sa applyan ng mga correction para matanggal natin yung mga systematic errors. Okay? So, the next topic will be probability. So, let's discuss what is the use of probability in eliminating the errors. So, diba, yung systematic errors natin is pwede natin sa applyan ng probability statistics para ma-determine natin if our data is reliable, our data can be compensated. So here is the next presentation, which is all about probability. Okay. So, an idea of this probability on your past subject. Okay, when you say probability, so by definition, is this the ratio of the number of times that an event should occur to the total number of possibilities. So, yung statistics yung una. So, when an event can occur in m ways, in a number of ways, and fail to occur in n ways, the probability of the occurrence is m, which is the number to occur over m plus n. So, yung probability naman niya to failure is n, that is the ways to fail over m plus n. Okay. So, for example, yung random error from angles and distance, so yung reading natin sa angle and distance means dalawang event na siya, a compound event. One event is the angle measurement and other event is the distance measurement. So, this causes reverse closure. So, the probability of the simultaneous occurrence of two independent events is the product of their individual probabilities. Okay. Okay, let's go to the most probable value. So, this is the MBV. Again, this can be calculated if redundant observation have been made. So, pwede lang siya kunin if redundant yung ating pag-observe ng mga values. So, the formula in determining the MPV, this is just the average of your redundant observation, where M bar, that is your MPV, summation of M, that is the summation of individual redundant observation, and your n, that is the number of observation. Okay. So we have here residual. So the difference between the most probable value or your MPV and any observed value of the quantity, which means yung individual measurement na ginawa mo within that redundant observation, and it's in equation form, that is V, which stands for the residual, your letter V, your M bar, that is your MPV, and your M, that is the individual measurement or individual measured quantity. Another term we have here, okay, so the elementary concepts of probability in survey, since the random errors, yung ating mga random errors nga, kahit natin natanggal na natin yung mga systematic errors and yung mga blunder, yung random error natin is always exist. So, since random errors are dealt with probability models, so nakukuha lang siya and identify lang siya if we are going to use the probability, knowledge of that concept in probability is very essential. So, kailangan natin may knowledge what else the probability. So, one concept when in probability model arises is the frequency distribution. Are you familiar with the frequency distribution? Ito yung bell shape na normal distribution. So, this is the frequency distribution. So, gaano ka-frequent yung isang error mag-occur in that instance of observation. Okay? So, I have here an example. So, this is the angle observation from a precise total station instrument. So, maraming beses niya sinukat yung isang angle. So, we have here. So, yung mean observation na from this 274319, as you can see. So, the number of observation. So, here. So, one time niya binasa. So, yung residual. So, 274319, yung second niya na reading. This one also next. You have the number of observation. You have 2, dalawang beses na binasa. This one is 2, 2, and so on. So, if we take the sum of all the individual observation, if we take the sum of this, and also this one, so we can get the mean of 2494 angles divided by 100 kasi 100 observation to all in all. So, the most probable value is 27 degrees, 43 minutes, or 24.9 seconds. So, maski na total station yung ginagamit and you use the target of the prism, hindi talaga imposible na yung mga value is the same all throughout 100 times of observation. Maski repeated na observation, 100 times mo ginawa, hindi pwedeng, it's impossible na yung value is the same all throughout 100 of observation. Yun yung definition natin kanina. So, the most probable value of this observation, you take the sum, and the number of observations, so nakakakuha tayo ng MPV nga this one. So, paano natin nakuha si residual? So, this is just the difference between the MPV and your individual na mga measurements. So, ito yon 54, 4.9 in seconds. I guess this is in seconds. So, in seconds lang yung difference niya. So, in that similar data, yung kanina yung pinakita ko na 100 times niya ni-repeat yung observation. So, this is the size of the residual. So, this is the normal distribution na nakuha natin during the observation. So, as you can see, this is a histogram or a frequency polygon and a normal distribution curve of residuals from the angle measurement made with the total station. Yung residual, yung difference na ni MPV and the individual observed angles. So, as you can see, normal, when I say normal distribution na, yung shape niya, naka-bell shape, yung kanyang value. Okay? So, these are the summation data kanina. So, this is the ranges of class interval and the number of residuals in each interval. So, napapansin nyo, we have here, so these are the number of observed or the number of observation na na-fall within this value, which is negative 5.95 to negative 5.25. So, isang repetition lang ang na-fall. Next naman, we have here, for example, sa negative 0.35 to positive 0.35, which means medyo accurate na yung data. So, mas marami yung ating nafo-fall na repetition. So, as you can see on the, kung na-observe nyo sa number of residuals, di ba, the increasing siya, pagdating niya sa peak, which is the 14, nagdi-decrease na siya. This is the peak, which is the 14. And after that, it goes down, nag-decrease na naman yung value. So, if we graph this one in a normal distribution, so makikita nyo mamaya yung distribution niya. So, the sum of this individual observation is 100, so which is the number of repetition. So, I'm here in the next. So, this is now the output of the normal distribution. So, yung horizontal line, ito yung size of the residual. Ito yung negative, kanina negative 5.25 until sa pinaka-positive. So, from the left is negative and 0, 0 here, and a positive. So, makikita nyo, and the residual which is very closer to 0, which means very close siya sa tina-target natin na value or pinaka-MPV natin because yung difference niya sa MPV and yung individual na measured mo is almost 0, which means malapit mo nang ma-target or accurate yung data mo, high yung kanyang interval. So, high yung 14 kanina. So, 14 measurements are closer to this value. So, nakikita nyo this sa baba, we have E90, we have E95, we have the sigma, this one, this our sigma. So, take note of this one. We have also the inflection point, kung ano tong mga to. So, this sigma, ito yung tinatawag nating standard deviation, and we are going to discuss this on the next slide. We have also the percent error. Ito yung E95 natin. We have the E50. Yung sigma natin, ito yung ating tinatawag na E50. So, we have also E90 and E95. So, anong gamit ni normal distribution curve para ma-analyze natin yung ating mga data? Okay, so let's discuss this one. So, we have the general laws of probability. So, we have number 1, small residual or errors occur more often than the large one. That is, they are more probable. So, this is more. So, yung difference ng ating MPV and yung individual natin na mini-measure, most probable siya na mag-occur. And number 2, we have here, large errors happen infrequently. So, hindi masyadong nag-a-appear yung ating mga large error or yung tinatawag natin yung mistakes. And therefore, less probable siya na less yung probability niya. So, for more normally distributed error, usually yung ating mga large error once be a mistake rather than a random error, which is correct. So, mistake na siya. So, ang ating mistake is hindi naman usually nag-uukor. So, the positive and negative errors of the same size, either kung naging positive yung kanyang error or negative, happen with equal frequency. Kung nakikita nyo kanina from negative na residual to positive residual, so the same yung kanyang number na occurrence. So, that is, they are equally probable. Okay. So, napapansin nyo, so there are two types of the normal distribution. Ito yung tinatawag nating increased precision. So, yung data natin is more closer to each other. And we have also decreased precision. So, nagpa-flatten yung ating curve. So, we have here now discussed the standard deviation and the variance. So, the standard deviation, yung nakikita nyong sigma kanina at the bottom of the graph. So, we have here take note that the magnitude of dispersion, when you say magnitude of dispersion, gaano ba ka-disperse yung data or gaano ba ka-disperse yung data within the normal distribution curve is an indication of the relative precision of the observation. So, kung gaano ka-disperse yung ating value, kung medyo increase yung pointed yung ating graph, which means masyadong precise yung ating mga measurement, individual measurement. And we have here Uh, so other statistical terms more commonly used to express precision of groups. So yung ating commonly ginagamit is the standard deviation and the variance. So, yung ating tinatawag na sigma, this one is a sigma. Ito yung ating tinatawag na standard deviation. So, yung ating standard deviation is plus minus the square root of the sigma v squared and minus 1. So, yung ating we have here where yung ating sigma is the standard deviation of a group of observation. Remember, this is a group of observation. Have n, that is the number of your observation. The v is the residual of individual observation, which means the difference with your MPV and your individual measurement. Okay? So, isasama mo siya and your v squared. So, you encounter this one in your GE 113 elementary, the theory of errors. So, let's go with the variance. So, si variance naman is just the square of the standard deviation. So, square root lang siya ng standard deviation. Okay? So, this is a part of the normal distribution. For example, yung normal distribution natin, slice natin siya at this point here. So, this is the relationship between the error and the percentage of area under the normal distribution curve. So, at this point, 3 sigma. So, this is 0, 0.5 sigma, 1, 1.5. This is the error, ha? And this one is the percentage area under the probability curve. So, this is the percentage. Ito na yung E90%, E50, and E55. So, we have here the inflection point. Makikita natin ang the inflection point, which is here. So, makikita nyo si E95, E90, E95. In the graph, saan ba si E50? So, at this point here, this is 50%. So, at 50%, if you observe this value, observe nyo si value, di ba? At E50, which is, yung value na is 0.6745. Are you familiar with 0.06745? Diba, ito yung constant na minimultiply natin sa standard deviation, diba? So, plus, minus 0.6745 to determine the standard deviation of a 50% error. Ito yung ating 50% error. So, how about si E90? So, 90%, look at here. So, yung constant niya na gagamitin natin to multiply the standard deviation is the 1.6449. So, 1.6449. How about si E95? Si E95 naman, nandito siya. So, yung constant na i-multiply natin is 1.9599. So, what are the use of this E95? E90, and E50. So, alam na natin si E50 ba? Diba? Si 50% error. So, let's discuss this one. So, the E50, the E95, and E90% error. So, the probability of an error of any percentage likelihood can be determined. So, the general equation is yung ating percent error is equal to the C, which is the corresponding numerical factor, and the percentage error natin yung AP, and the standard deviation, ito yung ating standard deviation. Okay. So, let's start with the percent error. Ito yung ating alam ni na probable error. By definition natin sa elementary surveying, yung probable error is the 50% that the value of the observation falls within the value. So, it established the limits within which the observation should fall 50% of the time. So, ito na yung formula. So, nagtatanong kung saan ba natin kinukuha si 0.6745. This is coming from the normal distribution curve. Okay? Times this one, sigma error, this is sigma. So this is a plus minus the square root of your b squared over n minus 1. Diba? So, are you familiar? If you go back to this, to your surveying, so that is 50-50. So, which means this value falls within in or out the range of the value. How about naman si E90? So, A90 and E95, this is commonly used to specify precision required on surveying. So, gaano ka-precise yung ating survey? So, yung ating E90, so E90, so this is called the one, yung value kanina sa E90, which is 1.6449, multiplied by this standard deviation. So, if your survey falls within this E.90%, which means your survey is precise pa siya. Your E95 naman, so they have here, this is also known as the 2 sigma error or 2 sigma, computed as 1.9599 multiplied by your sigma error. Okay. So, we have also the 99.7 error. So, kung nakikita nyo kanina sa graph, we have the 90, 95. So, yung pinaka-last na, we have the 99.7% error. So, yung gamit ng 99% error, 99.7% error is to identify which observation or which data, it's, for example, 100 times niya mineasure yung kanyang, mineasure yung angle, and if your value falls within 99.7%, which means that value is a mistake. So, kailangan mo siyang tanggalin within your data para maging, para walang mistake yung data mo to avoid large type of errors. So, this is the use of your E99.7%. So, determine kung anong data yung mali na pwede mo siyang tanggalin on the data. So, this is also known as the 3 sigma error. So, it is often used as a criterion in rejecting individual observation. So, kung this data, itong isang repetition falls under na 99.7% error, so, pwede mo siyang i-reject. So, pwede siyang tanggalin sa data para mas magiging reliable yung data mo. Because tinanggal mo na yung mga mistakes and large errors. Okay? So, I have here a sample problem. So, let's solve this one. It is assumed that no mistake exists. So, wala siyang mistake. So, probably walang ma-fall na data within 99.7%. And that of the observation have already been corrected of all the systematic error. Which means, yung nare-remain na error within this data, kasi tinanggal na yung systematic error, so nare-remain na lang is the random errors. Now, you are required to compute the most probable value. So, kukompute natin yung MPV of the length of the line and the standard deviation, which is yung sigma, and the errors having 50%. So, anong mga observation ang mayroong 50% na error, which falls within the probable error? We have the 90% and the 95% probability. Okay? So, kung makikita nyo, ilang beses niya na measure yung length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10 times niya ni-repeat pag measure yung isang line. So, if you can observe on the data, kung closer ba o hindi, yung kanyang mga measurement. Then, I take the sum. So, this one is the residual. Okay? So, the residual na niya, yung MPV minus this individual observation. So, nakakuha siya ng mga residual. This value, this one. So, hindi pa siya naka-arrange in the, na ipa-plot natin siya sa normal distribution curve. Hindi pa siya naka-arrange. So, this is the residual squared. So, this is the square of this value lang. Ito nga na mga value. So, 0.014, 0.036, and so on. So, this is the summation of the residual squared. and the summation of the residual. Okay, so this is always 0 if tatanggalin na natin yung mga systematic error, yung ating residual. Summation ng residual. Okay? Let's look at the solution of this problem. So based on the solution, if you are going to check to compute the MPV, so MPV is just yung ating na-compute na pinakita kanina na summation ng observation divided by n. Yung n natin is 10. So yung answer niya na MPV is 538.45 feet. So this value, igsasubtract natin siya sa individual natin na measurement para makakuha tayo ng residual o yung ating V, yung nakatabulate kanina. So, the residuals are calculated, so they are tabulated in column. So, for observations of equal reliability, so by equation, so this is the solution. So, if our number one required is the sigma, or yung standard deviation, this is just the square root of the summation of the v squared minus n minus 1. So, get the correct answer, which is this value. So, yung ating standard deviation. So, by equation, yung ating E50, so you just multiply the standard deviation with the 0.06745. So, makakuha tayo ng value. So, this one. So, this is the probable error. Ito yung ating probable error. By equation naman, plus minus, if we can compute if the data is precise, 1.64495. Ito yung gamit ni E95 and E90. So, the value is this one. And we have here, for the equation, E99. So, kinuha niya yung mistake, pwede tanggalin, i-reject. You have 1.9599. So, this is the answer. So, and if you are going to analyze this data, so the residual that falls within plus minus 0.05 is accepted because probable error siya. So, if the data falls within 0.1013 plus minus 0.013, those are data that are precise. So, that data that falls within out of plus minus 0.15, so those data are rejected. Okay? So, the most probable value is this. So, this is the explanation of the computation, yung MPV na nakuha natin. So, the standard deviation of a single observation is this one, to remember the data. So, accordingly, normal expectation that 68% of the time recorded length will lie with this value. So, plus minus yung MPV, plus minus yung ating nakuhang standard deviation, so 583.08 minus this standard deviation and MPV plus, so which lies between 538.37 na diba, and 538.53. So, 7 values should lie within this limit. So, yung mga value na fall, yung mga individual measurement na fall within this value are the 60% of the time na recorded length. So, pasok siya. So, we have here the probable error, E50, yung ating E50. So, 0.05, yung ating nakukuhang E50. So, yung explanation siya, therefore, it can be anticipated that half or 5 of the observation will fall in the interval of 5.38.40 and 5.38.50. So, you take the sum and subtract from the MPV. So, yung 90% error niya, we have here, yung na-compute natin is 0.13. So, thus, 9 of the observed values can be expected to be within the range of this value. So, also compute the 95%. So, ilang percent ang na-fall within this value. So, pag na-check nyo, i-check nyo lang doon sa individual observed data if this data is 95%, yung data ba na to is 90%, o yung data na to is 50%. Okay? So, I have here a practice problem. So, we have a 20 of measurement with angle. which are given on the table in the next slide. So we're going to compute lang the mean angle and the standard deviation and the standard deviation of the mean. So for we have here the data. You can solve it at home. For next, we have example number 2. I will give the copy of this on the activity that I will be sending you in the email. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10, 20 observation. We have this, the length of the line, measurement of the length of the line, 20 measurement niya. So you're going to compute the mean of data set, the variance and the standard deviation of the data. So what is the standard deviation of the mean? How many observation falls under the E50, E90, and E95, and also E99.7. So I guess this is all in this presentation. So you have any questions, you can comment on the Facebook where I can post it this video. So see you on the next topic.